Hi and welcome everyone. Welcome to Programmers Week. We're kicking off with the first presentation for today. This year, it's obviously an all digital conference. I hope with the current pandemic situation, everyone is safe and well and adapted to the new ways of working from home. My name is Răzvan. I am an iOS developer, and my everyday job is to develop great experiences for our clients and our customers. And for this, I need to make my job easier to understand and iterate over it. And for that, I need something to do so. And in these presentations, hopefully you will find something that will help you with your work. So the talk is called Functional Elements of Swift. To give you a bit of context, in 2014, Apple introduced a new programming language called Swift. It came as a replacement for the already old Objective-C, and it already felt like a fresh breath of air because the syntax was modern and it was really time for a change. And immediately people started wondering, what kind of language is Swift? Is it an object-oriented one? Is it a functional one? Well, we found the answer in 2015 that it's actually a protocol-oriented language, but still it has something inside it that people thought that it might be a functional one. And why was it functional? Let's talk about a bit about functional programming. What is it? In a nutshell, functional programming is all about immutable state. It promotes immutable state. How we do this in Swift? Well, if we open a playground with some Swift code, we're going to see that the way we define properties in Swift are with a keyword called var. Var means it's a variable. That means it can be changed. So we can do something like this. But this means if we mark a property as a variable, we open a Pandora's box, and in that scope, everyone can actually change it. So we don't want this. What we want, and we might consider doing, is actually changing it to a constant, made up our minds from the beginning. And this operation, if someone tries to change this later, it's illegal in Swift. And the other thing that I want to talk about in the context of functional programming is actually functions. And functions in Swift are really cool. They get superpowers, meaning they are considered first-class citizens, which basically means that we can store them in properties and pass them around. So this is a valid Swift code. We define a function like that. The other options that we have is to store functions inside a property. In lack for better naming, I'm using the classical foo and bar. And the coolest thing that we can do here is that we can actually assign the foo function to the bar variable. That's only valid Swift code. And with that, another cool thing that we can do, it means that we can pass functions around as dependencies. And in this example, we have some activity tracker for the user. And that we can send it to a controller instead of just sending an instance of activity track and open up all the methods that it has to the settings controller. We only send it the piece that it needs, which is the track action method. So what other things we can do with functions? Well, if we can pass them around as dependencies, it means that we can probably pass them as parameters to functions. They are called higher order. These kind of functions are called higher order functions. And if we take the example from before with the foo, the way we might pass the function here would be like this. And this means we have access to the bar functions inside the scope of the function, and you can call it like that. Yeah, pretty simple. And when we call the foo method, we call it with like this with a reference to an already existing functions, the method from before, or we can make use of some sugar syntax and declare it on the spot with a trailing closure like this. So this why are these higher order functions useful, and how we can make use of them in the Swift language. We take an example, and usually when we work with data, we get data like this with the zeros and ones and twos, and really we shouldn't work with it like that, because we understand the data now, but we might not understand it later, or worse, our colleagues will not get what we're actually doing. So in this example, what I'm trying to convert is the data array to an element status array. So what I would do it in a traditional way is to first create an accumulator, an array, which is empty, then iterate over each element in the data array, do some transformation functions, and then append an element inside the transform. And then in the end, we end up with a new array with these elements. And this is all right. This is okay. This is valid Swift code. But we encounter some problems here. One of them is that we open, as we previously discussed, the transform array to changes inside the scope because it's a variable. And the second problem that I'm seeing here is that every time I'm iterating over, and I want to iterate over data, I have to declare a new for in syntax, and then inside it I have access to and do some other strange behavior that I might not want. So my intent here is to actually protect my code from changing, and side effects that might be introduced, maybe or either by me or by someone else. So it turns out that this behavior of iterating over data, transforming it and returning it into a new array, it's pretty common. And if we have a pretty common behavior, we might make we might encapsulate it in some way. And it turns out in functional programming community, there's this method called map. And map, the way we write the syntax from before with map is like this. Again, we have the same result, nothing changed here, except that now the transform array is now a constant. This means that it can be changed. We can't append other elements inside it. And the functions, the trailing closure for the map, because map is a higher order functions, the function that it accepts, doesn't allow side effects because it's a pure functions. But still, we see an improvement, but really we can do much better with extracting the transform logic from the inside to a separate function. And then we can call the map method with a reference to that functions. And then what we gain here is simplicity at the call side. We can read it really easy data mapping to optional status, right? And then we get another testable simple functions, pure function that has no other side effects of behavior, right? But I kind of lie to you, and we don't really need this pure function to optional status, because it turns out we have another pure functions that comes free with the element status enums, which is called an initializer. So all this logic that we've written before can be written just like this, sending a reference to the initializers for the element status. And we see immediately that we have a lot less code, and we could do the previous logic with only this information. So we are already gaining something. And one thing that really bothers me is that the 2 was not interpreted as nothing. It's a nil. And how we might get rid of it is, of course, check for another functions. And it turns out there's one that exists called compact map. And compact mapping means that we are mapping over the elements, and we filter the nulls. And that's really the thing that I want to make an emphasis on now is that every time we iterate over the elements of an array, we might reconsider it and look for a higher order function that already does that. And it seems that there are many of them implementing an array. They really express the intent, and we can take advantage of them. And I strongly encourage you to look for many of them. Here I listed only some of them which I consider really important. Right, so now that we got to look for what we can do with functions and higher order function in Swift, where else we find them? And it turns out we find them on optionals. Optionals are, if you program in Swift and you learn Swift, are really interesting, because at the beginning you find them, you might find them confusing, but then you learn to appreciate the power that they have. And how we might think an optional is really like a box. We know what's going to be inside them because we know the type of the optional. And how we usually work with them is to open the box, see if we have something in there. If it is, we take that out and then we do something with them. And then really interesting scenarios that when we look inside the box, we take that thing out, we transform it, and then we put it inside. So how we usually would do when working with optionals, I have an example here, property called status as string, which is an optional string, and then I want to convert it to a response, which gets a status. We can immediately see that the status is a string, a simple string. So what we have to do is, again, we're coming back to that example that I was describing about optionals, take the string from inside the box and then initialize a response with it. And how we do this in Swift is by using an if let. What that basically is saying is that I'm taking the status after the status string if it exists, and then I'm initializing a response with it. The response is, again, has to be a variable, right? If we want to use it outside the if, and it has to be optional itself, because we might not have anything inside the status as a string, and that means that the response will turn out to be null. So how we can do this with map? Well, map is not really iterating over elements and transforming them and putting them inside. It's really about transforming what's inside the container. We can think an array as a container, right? And we are transforming the elements inside the container. And if we think optionals, again, as a container, we map what's inside the optional. So the previous example, right? If I'm just expanding the map method with a trailing closure, is what map does is take the status out as a string this time, and if it exists, it will initialize a response and then return it. And we see that we gain the immutability from before because we mark the response as a let, right? But really, we can do what we previously did and just send the reference to the response initializers that we got for free with the structs, right? And if we check the type for the response, we see that it's an optional. Again, we might not have anything inside status as a string, it might be a null, so the response automatically becomes a null. So let's see a more complicated example. We want to go from the status as string to an HTTP status, which is an enum with a raw value of an int. That means we have to go from string to int and then from int to HTTP status. Again, we can achieve this with conditionally unwrapping. We get the string from the status as a string. We then initialize an int. and with that int, we can initialize an HTTP status. Yeah, this is valid code, and this is how we usually do it. But I think it's a better way. And then, and because I showed it before, and you might guess what comes next, is that we go over the status as a string, we map it with the int initializer, but we end up with something that looks kind of strange, which is an int with double question mark with what does this mean? It's like a double optional. What is it exactly? So to how we can think about it is like a box that has a box with something inside it. So it's a double nested block. So what really want from this is just only one box with an int inside it. So it turns out, again, there's another method to do this, which is called flat mapping. Flattening means really squashing the one of the box. We see now, if we check the type for the status as an int, it's what we expect it to be, which is an optional. The double optionals, it's really a valid type, right? It exists because it only makes sense for it to exist, because we end up with these operations to it. But really, we don't work with double nested optionals. What we want is really an optional, right? So what we can do, what we can continue with, is to flat map over the HTTP status in it. Why we are flat mapping? Because again, HTTP status might return a null, and it's the same case of a box inside a box. So immediately we see that the code from before, which is this, was really simplified to the first iteration, and I will always take this, because it really expressed the intent and what it's doing. Okay, I have one more case, which is error handling, right? An interesting situation where we might end up with inside our apps is to validate a phone number. And what we have to do is to check the phone number. We have to update the user. Maybe we have to send an SMS, and then we have to update the status, telling the user that the SMS was sent or not. And that's what's called the happy path. In reality, we might end up with different kind of errors, which in this case can be an invalid number, right? If we try to update the user, we might get an update error. And if we are sending the SMS, the SMS might not be received. Again, we have to show these errors to the users. And what's interesting here is that at any level, the flow can fail, and we have to propagate the error down the stream up until the end to show the appropriate error. So how we might do this in a classic scenario, we might have some methods that verify the phone number, update the user, and then send the SMS, and then a method that assembles them. And that's really a naive implementation, but it can work for us. It can work for us. It looks right. It's beautiful code until we start adding error handling. And I think, and my guess is that's why we don't do error handling, because we don't want to mess up with our beautiful code. Because if we want to add the handling of failures for the if the phone number is valid or not, we have to add a check like this. Then we have to check if the update user turned out to be a success or not. Same for the SMS, and it already looks like, yuck, it messed up our code pretty bad, right? So how does functional programming and really what from Swift helps us to achieve a nicer code, let's say? And it turns out in Swift 5, there's a new type introduced called result. Result is similar with optionals in the sense that it has two cases. One is that it's a success and the other one is a failure. Both of them can have information about what was a success and what was a failure. And an instantiation for the result that contains an int looks really like this. We have to define what the type of the container is. In this case, it's an int, and then and the type of the error that might result down the stream. And because it's because we saw it in the optionals that map functions can really transform containers. Of course, result has a map functions itself. And in this case, if we are mapping over the result, and we know we do the square of it, the new result, we see that it's going to be a success, but the value that's going to have, it's going to be the one that we transform inside the map. So in this case, it's a 9. And what's interesting about the result is that if we switch it to an error, right? For example, we get a phone number error and we map over it, it's going to propagate the failure down the stream because it has nothing to transform. And then the new result will have the failure of the previous result. And that's really important because it looks like it's something that we originally needed to. If at any point we have an error, we have to propagate it down the stream. So if we update our functions to return a result, really the update status method changes to this. We have a method that will handle the result, either if it will be a success or a failure. But what we are doing there is really chaining the methods one after the other. And we see here that we have flat map. Yes, the result has the same problem as optionals, which is the case of a double boxing. What we can end up with inside here is with a result inside the result. And we usually don't work with them like this. We have to have one result at the end. So with the previous example, we chain the method like this, and we send the reference to the method to the flat map functions, and that's already feels better. First of all, because we reduce the size of the code, and another thing is that we have only one method that checks for the success and for the error and has all the information available to update the user with the correct status. But I think we can do better, and I'm going to show you an example of a more advanced thing in Swift, which is defining custom operators. This one is called a pipe operator. It's pretty common in other functional language, and the way we define an operator is really we have to define where it goes. In this case, is an infix, and we have to tell the compiler that it's an operator. And an operator is really another function. I did the angle brackets from there means that it's a generic method because it's going to accept multiple types inside them, right? And what it does, it's going to take a property, a type, and then a function that goes from that type to another type, right? And it's going to apply the function to the original property. And to show what this really means is that when we call a method, we the way we do this is the way we generally do this is we think of the method, and then we we think about the argument at the end. What this code goes to with now with this operator is we think from the phone number, we're going to pipe it to the verify phone number method reference, right? And this way it changes the way you think about what data and how data is going through your chain of methods. And now that we have this operator, and then we change a bit the structures of our functions to not only accept a phone number, but a result to them, the original update status method updates to this. And what this might look confusing. This is not ordinary Swift code. It's not how we usually program stuff, but it's valid Swift code in a sense that you can actually define it and use it like this. And it already we see one benefit here, that and that means that it reads exactly like the original schema that we have, where we define all the flows that we go through to validate the phone number. So that's easier even for the project managers to read it. And how this chain translates is the phone number will be fed to the verify phone number method. Then we're going to have a result, which is going to be fed to the update user method, and then update user method will do the same until we reach at the end with the handle result method, where again we have only one single point where we handle the error. We don't have to check at every level and propagate that. So yeah. Let's see, in the end, let's see some drawbacks to coding like this. One of them would be the lack of knowledge inside the team. Not many people are aware of this functional ways of working. Not many Swift developers know the existence of these methods. So if you program in this way and the others are not familiar with them, when you introduce the pull requests, it might be kind of confusing for the other teammates. And what really we need to do is we have to raise the intellectual property inside the team, and teach them, or maybe show them with examples how these things work, and why is it better for them to be aligned. Longer onboarding times, again, because we have to teach them and we have to introduce them to this new ways of working. This means that inside our code base, we might get longer onboarding times for the newcomers, because they have to understand not only the way things work inside the language, but how we do it inside the app. Another thing is being too clever. What I showed you before can be a bit dangerous if you don't know, if you're not familiar with, custom operators. For example, you're gonna do your own operators with like stars and dashes, and you might end up in a situation where the code, it's nice, it's clean, it's short, but then people don't understand what's going on there. So being too clever, it's not really an option when working in a larger team, for example. And why? And one last one, which I'm 50-50 on it, is sacrificing performance. We show that there's this map method on the arrays, on the collections. actually. And what we are doing with this method is like iterating over them. And then if we chain them together, for example, in like a map, flat mapping, compact mapping, filtering, and everything, we might at some point sacrifice in performance. But it really comes down to your use case, because we usually, and I usually work with small arrays, and I'm sacrificing performance for better readability where is the case, you know. But if your case is, you know, optimizing and squeezing every bit of performance from the processor, you might look at something else. And let's see what we win. What we win really with this is like, we know that we have to know the programming language at the core. We win, and I recommend you to know your programming language, because you know, smarter people are constantly working on improving the language, adding things that make you productive. And we noticed how you know, the benefits that we gain from actually using other things than the traditional way of working with the programming language. You again, you might reconsider your for loops and use one of the predefined methods. Again, what we learn from them is the safety of the code. We get the safety from immutability, and we get better readability because these methods are really, and functions are really named in a way to suggest what they are doing. Keep your functions pure. This is really a really nice and an important thing in functional programming, to make your functions get inputs and outputs, and don't do any side effects inside them. Side effects means, you know, in that example where we were converting an int to an enum, we might, for example, update user or send a notification or something. We don't do that because really a function has to do, and it's recommended to do what it tells, you know, no side effects for that. So you might think of keeping your functions pure. And the last thing is handle your errors. That's you know, a pretty good advice. And we saw that handling errors might not be that hard and that, you know, horrible with the right tools. Okay, so that was it. That was my presentation. We're gonna thank you everyone for joining. We're gonna take some Q&A now. And let's see how I might do this. All right, so I have only one question from Sergio, which again, I forgot to mention this. There's on the Zoom call, if you join the Zoom call, you have a section for the Q&A, right? You can answer that, and I'm going to go through them and answer them one by one. I see people already have some questions there. So again, Sergio asked, what does init do in enums? So enums in Swift have an interesting case that every case that it has can have a raw value. And we saw the example where we have the enable or disable, which can be zeros and ones, right? So in this case, we can initialize an enum with a zero, that enum with a zero, and then get the according case. And we saw the example with the HTTP status. If I can go back a bit, which is like here, right? So here we can see that we have a raw value attached to them, and if we want to get from an int to an enum, we can initialize the enum with an int, and then we get the according case. In this case, if we do it with the 200, it's going to return okay. Right. Okay, next question. So Christy is asking for the SMS flow. We could achieve the same result with declaring all functions as throwable. We'd get a similar linear flow. What would be the benefit of using the pipe operator? That's true. In my case, I did a do catch block, two different ones, but you can actually do it inside it. Inside only one catch. The pipe operator in this case gains better readability, in my opinion. And the other thing that you get is really you can compose, you know, functions one with the other instead of just using the, you know, the classical throwable thing in Swift. Okay, and the next question from Christy is: functional programming seems to work best with one parameter functions. In your experience, is this something feasible for mobile apps? Yes, that might be true, but there are cases where you can. It's not really related to mobile app development, because in my examples, which were oversimplified, I was having an input and one output, but really combining functions and chaining them can be done with multiple parameters. So if you find a way to combine functions with multiple parameters, you can do that with no problems. You just have to match the inputs, the output of a function with the input of another in order to combine them and chain them together. So I think it's feasible. Just watch out to not overcomplicate things. Okay. And I have an anonymous question here. Hello, the first version of Java language was released in 1995. In your opinion, does the Swift have all requirements technical to stand up as much as Java? Well, I think it's really Swift and comes really from a different place, and Java over the time has matured and went to the old transformation of the the way we program today, the how the web evolved and everything. So the advantage that I see with Java is that, and it's still it still continues, that it's a cross-platform language. You can literally run Java anywhere, everywhere. There are efforts to port it to Windows, for example, at this point. Even here, but it was written by Alexander. Okay, I already answered that. Okay, so Sergio again asked, how simple is it to create a new type, like in F#, for example? You can do it. You can do what is called a discriminated union, and enums also that powerful in Swift. Okay, so full disclosure, I'm not really familiar with the F# and what a discriminated union is, but you can create your custom types in Swift, and that was the case for the result type, for example, because many programmers that were familiar with functional language were created their own implementation of the result type. There were a lot of, and I think there still are a lot of libraries on GitHub that help you with that. So they created that type, they used it inside. And then the Swift core language team looked at it, saw how important and how useful might be and how accepted by the community is, and then integrated inside the language, and now we have a unified implementation for it. So you can create your custom types, you can add your own methods, your own implementation of the higher order functions like map and flat map. Just make sure you what I would check is really if that was already implemented or not. So yeah. Okay, and Alexander asks, may I ask what software did you use for this presentation? Is this PowerPoint, MacBook Pro version? So I'm using a 13-inch MacBook Pro. This is 2016 model, and the software that I used was a Keynote. Yeah, that's what I'm used to. All right, thank you, Alexandra. Okay, so I think that wraps up the Q&A section. Thanks again for joining, and I recommend you join the other presentations as well. Look over the calendar. There are a lot of interesting things coming up this week. All right, well, okay, last question. On social media, I'm like everywhere, Rezvan BTR. Okay, that's it. Thank you. Have a great day.